Hi everyone, welcome back to Java 1 for All. In this video, we are going to talk about CompletableFuture. The feature that we were working on, they have several limitations. So, for example, the feature cannot be manually completed. What does that mean? Imagine that you are requesting the dollars to the TransferWise API, dollar quotation, and suddenly there is no service available. There is no option for you, for example, to have a fallback option like get a cached price or maybe check another API. So with Future, you don't have that option. Another thing is like you cannot perform any further action with Future without blocking. So with Future there is no option to have like what we call callback function. For example, imagine that we get the price and suddenly after getting the price we would like to apply a calculation over the money that we would like to convert. So Future does not have that option, or you cannot chain multiple features together because they were basically created on Java 1.5 and functional programming came on 1.8, which made everything much better. So CompletableFuture is a class that was introduced on Java 1.8, CompletableFuture. So we have all the advantages available, including the ones that we already have in the future. So another thing, they cannot be chained, you cannot combine them if you want, and there is no option for exception handling. So all these limitations from Future, they were solved with CompletableFuture. And here, let's do one quick example. Let's create a store service. Let's imagine that this store service is kind of comparing prices from different stores. So you imagine that we send like 5 stores for the argument, and we would like to get all the prices. So let's imagine that we have old methods that are synchronous and asynchronous with Future and CompletableFuture. So let's start with the regular synchronous one. Public, actually, let's first generate the price because we don't have anywhere else. Private double price generator. And this price generator will be pretty simple. First, we are going to print here with printf south. And I will say that this thread generating price. And then I will jump one line. And then let's imagine that we do have a delay when calling these APIs. Let's call private void delay. Then surround with try catch. And here, after we have this message, let's call delay. Here we are missing S. And then let's get a random number. Thread local random current next int from 1 to 500 multiplied by 10. And we just return. Okay, so we have the price generator. Let's imagine that now we are getting this price synchronously. Public double get prices or get prices sync, and let's ask for the store name. Okay, now sitting out printf again, getting prices synchronously for the store, and then jump one line, store name, and we are just returning the price generator. Okay, now let's go here and create CompletableFuture test 01. First, let's create a store service, new store service, and then let's create another method here, private static void search prices sync. Okay, so I want to start with for stores, and I want to check the time. So long start system current time minutes, and then south. Let's ask the start service here, the argument, and then start service. I think we can call on service. Okay, so service, and then get price sync, and let's give store1 as name, and then Control D 4 times. 2, 3, 4. And then copy this one, rename it to end, and then again so %d milliseconds, and then jump one line and minus start. Cool. Now we call this method, and then we pass start service. So basically, the old way doing synchronously, this will take at least 8 seconds. Basically, the main thread is the one generating the price, going store by store, and that's why each store is taking 2 seconds. That's why we have a total of 8,000 milliseconds. So now we want to do this asynchronously, but let's do it from starting with the old way, using future. Since we are using future, we need to submit for exactors. So exactors dot let's create here private final static exactor service ex exactors. I'm going to use cached thread pool. So I just want to create as many threads as the store we are requesting. And I will get this, I will duplicate this method, and then get prices a sync prices future async. And here will be a future double. Okay, now we just need to call the submit ex.submit, and we pass this price generator. Another thing, we have to shut down the exactor. So let's create a method here, a public void static void shutdown. Well, I can, since this is final, I can make this public here, and then I call the shutdown from the service. Let's copy this. Future async. So things will stay the same, but there is one very important thing. First, we call the store service dot exactor dot shutdown. Now, one of the problems is like we cannot just call the get prices feature async directly here. So if I replace all of this and I call get here, first we have to handle these exceptions. So surround with try catch. Then I will copy all of this. I will move up, Control Shift up, and then if I execute this now, calling here, we will have a problem. Which problem? We are going to use synchronous programming. Even though we are using the exactor, by executing now, you will see that we have only one thread being used at a time. So thread 1, thread 1, thread 1. And why is that? Because we are creating, we are basically telling, hey, try to create a new, just call the callable, but right after, just get the value. So we are blocking. So what should we do here? We should split this. So let's copy this. Let's remove, holding the mouse wheel. On Windows, if I'm not wrong, is Control Shift 8. No, yeah, I never remember. Alt Shift 8. Yeah, I need to check that out. So going back here, I'm going to do the following. I will remove this, and then I'm going to move these guys up, and I will create local variables for all of them. Two, three, four. And then I'm going to copy these guys. And right here, I'm going to call .get. So basically, I am creating here the future tasks, and then here I'm getting the result. So let's see, Control Shift F10. So as you can see now, I have 4 threads from my thread pool being used, and then I have the, because I'm not printing here, I should add the print ln. Control Shift F10. As you can see, the time passed was 2 seconds, 2000 milliseconds. Why is that? Because basically the main thread came here, boom, 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 started all of them, and we just had to get the value. So we are not blocking anymore. So that's why you have to be careful to not just create the asynchronous method and right after you get the result, because then you will be blocking. Okay, so this is the future. We already know how to work, but what about the completable future? So the completable future is very similar. One of the key differences to get started is that the completable future does not require a executor. Let's change the name here to completable. So right now, I'm going to delete this, and I will call CompletableFuture, and then we have this nice method called supply asynchronously, and it's asking for a supplier. Then we can do the same. We can pass here the price generator, and I'm not going to use the executor. Let's see how it will handle this. So let's copy this method, and let's rename it to CompletableFuture async. And same thing here, let's copy the name of this method, and then let's rename here. But since the completable future is more specialized, we have to rename this guy as well. Otherwise, we won't get the result we are looking for. Then import the completable future. So basically, the code didn't change much at all, but let's see how it behaves. Going back here, Control D, replace this, remove here, and Control Shift F10. So as you can see, we are still using multiple threads, but not from the executor anymore. As you can see, we are now using the fork join common pool. So basically, the completable feature is going to take care of those threads for you. The same way as the executor, the one responsible for creating and stopping and handling the task execution is the fork join pool thread. So one of the differences that we already have, that's not the uses, we don't need to use the executor, is that we can also change here to join. What's the difference between join and get? Well, as you can see, join is not throwing any checked exceptions. And if we execute, we have exactly the same result. So we are going to talk more, but so you can see the completable feature, the supply async, allows us to chain the method. So we can get directly the value we are looking for, but we can also complete asynchronously, or complete exceptionally, or complete on timeout, or you can give a timeout and then you just do something, something happens with that timeout. So you have several options available that you can chain in this completable feature. But we are going to see that in future videos. For now, I just wanted you to understand how the CompletableFuture works and just have this nice class as an example. So let's continue in the next video. Bye.